So further, after writing this, I can split up into two terms. So I can write 2n jn of x as x multiplies to m equal to 0 to infinity minus 1 raised to m. First term I'm writing as n plus n into x by 2 raised to n minus m plus 2m, and this gets divided by m factorial gamma of n plus m plus 1. So that's my first term. Second is minus x summation m equal to 0 to infinity minus 1 raised to m into m multiplied by x by 2 raised to n minus 1 plus 2m, and this gets divided by m factorial gamma of n plus m plus 1. So now what we can do further, see, since non-zero term starts from m equal to 1, so I changed at m equal to 1. So now I write here 2n jn of x, and that is equal to x summation m equal to 0 to infinity, then minus 1 raised to m n plus m, and here we can write as x by 2 raised to n minus 1 plus 2m. The whole gets divided by m factorial gamma of n plus m plus 1 minus x. So we start with m equal to 1 to infinity, and further minus 1 raised to m x by 2 raised to n minus 1 plus 2m. Since I started with m equal to 1, so the first term we are substituted, so I got as 0, and the second I got as, so here I will be writing divided by m minus 1 factorial, because I have substituted m equal to 0, and here I get as n plus m plus 1. So further what we can do is, so let put m minus 1 is equal to k in second term. Second term means this term, and here for the first term we'll be making our standard Bessel function. So I write 2n jn of x can be written as x summation of m equal to 0 to infinity. I had minus 1 raised to m x by 2 raised to n minus 1 plus 2m, so there is n minus 1 here, so which can be changed to, I write m factorial, and in gamma I change n minus 1, so as I did minus 1, so I need to do plus 1, and further term I write my x minus x summation. This comes from k equal to 0 to infinity, because we are substituting m minus 1 equal to k, and further minus 1 raised to k plus 1 x by 2 raised to n minus 1 plus 2 into k plus 1. This gets divided by k plus 1 minus 1 and gamma of n plus 1 plus k minus 1, so which comes to be x, and this term we can write as jn minus 1 of x minus, let's write this as, since there is a minus 1 raised to minus, so minus of x, and further minus 1 summation k equal to 0 to infinity, and this comes to be minus 1 raised to k, the whole divided by, the next term is x by 2 raised to, this is n plus 1 plus 2k divided by k factorial gamma of n plus 1 plus k plus 1. So we can write 2n jn of x, that is equal to x into jn minus 1 of x, and further is plus minus and minus becomes plus. I can write this as, just it is in k, so let's write this as n jn plus 1 of x. So that proves my property. Let's start with the next property in my next video. Thank you for watching video in 5 minutes.